Gauteng, grade 10, 2023, November, paper 2. Question 3. In the diagram below, we're given the vertices of a parallelogram. So P is the point 29, then we have A, R is the point n minus 13, and M, so those are the 4 vertices of this parallelogram, PARM, which is this one. Then we're told that PMT is a straight line such that M is the midpoint of PT, which means that PM is equal in length to MT. And we're told that T the point 10 minus 3 is a point such that PT is perpendicular to RN. So this is a 90-degree angle. Then we have some questions. So 3.1.1, the first, says determine the length of PT and leave your answer in insert form. So for the length of PT, I've got the one coordinate P, the other coordinate T, and I can just use the distance formula to find the distance between the two. So the distance PT is equal to the square root of the x of P minus the x of T, all squared, plus the y of P minus the y of T, all squared. And then I can just substitute in these values. So x of P is 2, and x of T is 10. And y of P is 9 minus the y of T, which is minus 3. So my first bracket is going to be 2 minus 10, which is minus 8, squared is 64. And then the second one, I have 9 minus 3, which is 9 plus 3, and that's 12. And 12 squared is 144. So 64 plus 144 is 208. And when I put this in my calculator, I get 4 root 13. Units. Okay, then 3.1.2, I'm asked to find the gradient of PT, so that's MPT. And again, I have both of the coordinates, so I can just use the gradient formula, which is the rise over run, so the change in y over the change in x. So I'll have the y of P minus the y of T divided by the x of P minus the x of T. And I can just substitute in these values, so y of P is 9 and y of T is minus 3. So I'll have 9 minus 3 divided by x of P is 2 and x of T is 10. Then this is 9 minus 3, which is 9 plus 3, and that's 12, over 2 minus 10, which is minus 8. And I can simplify this fraction to minus 3 over 2. Then 3.1.3, I'm asked to find the gradient of AR. So I don't have the coordinates for A, so I can't use the gradient formula like we just did for PT, but I do know that this is a parallelogram, which means that the gradient of this line is equal to the gradient of this line since they are parallel. And I already just found the gradient of PT, and so the gradient of PM is going to be the same as the gradient of PT. This is just an extension of that line, which means that the gradient of AR is also equal to the gradient of PT, which is minus 3 over 2. Then 3.1.4, find the coordinates of M. So M is the midpoint of P and T, so I can just use the midpoint formula. So I'm going to say the x of M, or the xy of M, is equal to the midpoint of PT, and the midpoint formula says that I add the x values of the 2 points that the midpoint is between, and I divide them by 2, and I do the same with the y values, add them together and divide by 2, so I get the halfway of the x values and the halfway of the y values. So for PT, my x of p is 2 plus the x of t, which is 10, divided by 2. And then my y of p is 9, and my y of t is minus 3. So 2 plus 10 is 12, divided by 2 is 6. And 9 minus 3 is 6, divided by 2 is 3. So that's my coordinates for M. And I look back on the diagram, and that looks about right. Both of my values are positive, and the x value of M is 6. So I'm expecting it to be further than the x value of P, which it is, but less than the x value of T, which it is. And then my y value of M is 3, so I'm expecting it to be less than the y value of P, which it is, and obviously higher than the y value of T, which it is. Then 3.2, determine the equation of the line PM in the form y equals mx plus c. So to find the equation of the line PM, I need the gradient of PM, which I've already found. It's going to be the same as the gradient of PT, because PT is just an extension of PM. And then I need one of the coordinates of a point that lies on the line PM. So that can be P or M, which we found was the midpoint one, or even T, because it still lies on the same line, PM extended to T. So I'm going to choose to use the coordinates of P, and then I'm using the gradient minus 3 over 2. So I have my equation to find, my formula to find the equation of a straight line. So my x and y I'm going to keep the same, but in the place of y1 and x1, I'm going to write the coordinates of P, and in place of M, I'm going to write the gradient. So the y of P is 9, the gradient is minus 3 over 2, and the x of P is 2. So now I'm going to distribute the minus 3 over 2. And I take the 9 over to the other side, where I'll have 3, and the negative 9 is now a positive 9, so this is 12, and this is in the form y equals mx plus c. Then 3.3, we're asked to show that n is equal to 5. So n we were given is the x value of r. So for n to equal 5, I can use the reverse of the midpoint formula, because I know that RT is parallel to PT. I was given that in the question. So if these two are parallel, then it means that the gradient of RT multiplied by the gradient of PT must be equal to -1. So I know the gradient of PT already, which means that I can find this gradient of Rn. Then with the gradient of Rn, I'm going to equate it to the gradient formula, which is the rise over run of these 2 points, Rt. So I'm going to say that MRT is equal to the y of r minus the y of t, and the x of r divided by x of r minus x of t. Then the only value that I'm going to have unknown is n, and then I can just solve for n like I would solve for x in an equation. So the first thing I'm going to say is that MPT times MRT must be equal to -1. And MPT we found was minus 3 over 2. So MRT must be 2 over 3. Then by the gradient formula, I know that the MRT is equal to the change in y over the change in x. So that's going to be the y of r minus the y of t divided by the x of r minus the x of t. So I know what MRT is. I found that that was 2 over 3. The y of r I know is minus 13, and the y of t is minus 3. So I'm going to have minus 13 minus minus 3 divided by x of r, which is n, we don't know, that's what we're trying to find out, and the x of t is 10. Okay, so I'm going to multiply this equation by this denominator n minus 10. So I'm going to have n minus 10 times this fraction on this side, and then on this side I'm just going to be left with the numerator. Minus 13 minus minus 3 is minus 13 plus 3, which is minus 10. Then I'm going to divide both sides by 2 over 3. So on this side I'm left with n minus 10. And on the right hand side, minus 10 divided by 2 over 3 is minus 15. Then I can just take this negative 10 to the other side and it becomes a positive 10. So I'll have n is equal to minus 5. Then the last question, calculate the area of triangle RMT. So that's this one. So this is 3.4 and we want the area of RMT. And since this is a right angle triangle, I'm just going to use the half base times height formula. So it's going to be half. The base here is MT and the height is RT. Okay, then I'm going to have to find the value of both of these, the MT and the RT, and I can do that by using the distance formula. So first, for MT, I'm going to have the x of m minus the x of t all squared plus the y of m minus the y of t all squared. And I just substitute the values. I was given the coordinates for t in the question, and we found the coordinates for this midpoint m earlier on. So we found that m was the point 6,3. And in the diagram, we were told that t is the point 10 minus 3. So the x-coordinate of m was 6, and the x-coordinate of t is 10. And the y-coordinate of m was 3, and the x-coordinate of t, the y-coordinate of t is minus 3. So in the first bracket, we have minus 4 squared, which is 16. And in the second bracket, we have 9 squared, which is 81. So we have the square root of 97 for MT, and then we do the same for RT. And we're now using the coordinates of R and T. So the x of R was n, which we found to be minus 5. and the y of r is minus 13. So for the first one, we have 15 squared, which is 225. And for the second bracket, we have 16 minus 16 squared, which is 256. So we have the square root of 481. Then I was trying to find the area, so the area of this triangle RMT is equal to half of the base MT, which is root 97, and the perpendicular height. And I put that all in my calculator, and I get 108.00 units squared. Gauteng Grade 10, 2023, November, Paper 2. Question 8. In the diagram below, a polygon ABEFD, that's this one, is drawn. AD is produced to a point C that lies on BC, and AC is parallel to FE. Given that A is equal to 3x and B is equal to x and ACB is equal to 2x. 8.1 asks us to determine with reasons the numerical value of x. So straight away I can see that these angles that involve x are all in the same triangle. So the sum of all of these must be 180 degrees because of angles, interior angles in a triangle. Int angles in triangle ABC. So this is 6x equals 180 degrees, and that means that x is equal to 30 degrees. Okay, then 8.1.2. What type of a triangle is ABC? And give a reason for your answer. So I know that the angle B is equal to x, so it's just 30. And angle A is equal to 3x, so that's 90. And angle C is equal to 2x, so that's 60 degrees. So I've got 3 different values for all of the angles of this, all of the interior angles for this triangle ABC, which means that ABC is a scalene triangle. And the reason is 3 different angles. Then 8.2. In the diagram below, ABC is drawn, and we're told that AB is equal to BC and that B1 is equal to B3. So these two are equal, and we're asked to prove that angle E1 is equal to angle D2. So first I'm going to say that angle B1 is equal to angle B3, and that was given. Then we were told that this line BC is equal to this line AB, and since they make up a triangle, that means that the angle A is equal to the angle C, and that's because of opposite angles and the equal sides. Then I'm trying to prove that these two, E1 and D2, are the same. And to do this, I can use, so let's label that we've just found that C is equal to A. So to find the size of the orange angles, I can use exterior angles of a triangle. So I know that E1 is going to be equal to A plus B1, and I know that D2 is going to be equal to B3 plus C. But since I've proved that C is the same as A and B1 is the same as B3, then that means that E1 and E2 are also equal, because these two added together is the same as these two added together, which is equal to these, the orange ones. So angle E1 is equal to angle A plus angle B1, and that's exterior angles. And then similarly, angle D2 is equal to angle C plus angle B3. Therefore, angle E1 is equal to angle D2. Then question 9, for the first part 9.1, we're given a parallelogram ABCD, and we're told that it's drawn such that AD is parallel to BC and DC is parallel to AB, and we're told that AC and DB intersect at this point O. Prove that DO, this is DO, is equal to OB, and that OA is equal to OC. So if I want this line to be equal to this line, and I want this line to be equal to this line, then I can see that I can just prove congruent triangles for these two triangles, AOB and DOC. So to prove the congruent triangles, I'm going to say that D1 is equal to B1 from these alternate angles, because DC is parallel to AB. And then I can say the same about A2 and C1. Alternate angles are equal. And then I can say that AB is equal to DC, because I was told that this is a parallelogram, and so the opposite sides are equal. So then I can conclude that this triangle is congruent to this triangle, and if they're congruent, then that means that this side of the triangle is equal to this side of the other triangle, and this side of this triangle is equal to this side of this other triangle. So I'm going to start by doing the alternate angles. So the first one that I'm going to do is this C1 and A2. And that's because DC is parallel to AB. Then I'm going to do the other two, so that's these ones now, B1 and D2. And I used the same parallel lines. Okay, so now I have that this angle is equal to this angle, and this angle is equal to that angle. And then I just need a side, so I'm going to say that these two are equal. And that's because of upsides palm. ABCD. Therefore, the triangle AOB is congruent to the triangle DOC from side angle angle. Therefore, AO is equal to OC, and DO is equal to OB, and the reason is congruent triangles. Then 9.2, we're given PQRS is a square, and X is the midpoint of the one side of the square SP, and Y is the midpoint of another side of the square PQ. So for the first one, 9.2.1, we're asked to prove that these triangles are congruent. So SPY is congruent to this triangle RSX. So the first thing that I know about these two triangles is that this side SR is equal to this side SP because it's a square. So all of the sides of a square are equal length. And then I was told that X was the midpoint of this side and that Y was the midpoint of this side, which means that these two bits of the triangle, these two sides of the triangle are also equal, because if it's the midpoint of both of the lengths of the square, and if the lengths of the square are the same, then the midpoints are going to be the same distance as well. And then I can say that these angles are the same because I know that the angles of the vertices of a square are 90 degrees. So I've got two sides and the included angle. Then I can say that these triangles are congruent. So first, SP equals SR, and that's sides of a square. And therefore, SX equals PY, and it's for the same reason. Then angle P is equal to angle S is equal to 90 degrees, and that's because of vertices or angles in a square, let's say. Okay, so the SP being equal to SR, that's these. And then the SX being equal to the PY, that's these. And then the angles being 90 degrees is these. Okay, so now I can say that this triangle is congruent to this triangle, and that is side included angle side. Okay, then 9.2.2. Says that given R1 is equal to X, so this is R1, identify with reasons another angle equal to X. So I noticed that this R1 is in the triangle that I just proved congruency with this triangle. So if this point of the one triangle is equal to X, then in the congruent triangle, the corresponding point is S1, which is also going to be equal to X. And that is congruent triangles. And 9.2.3, prove that SY is perpendicular to XR. So I can do that by proving any one of these points, 0, 1, 2, 3, or 4 are 90 degrees. Okay, so I'm going to start by saying I was told that these two are the same, this R1 and S1. So S1 is X and R1 is X. Okay, and I know that the angles in a triangle, the angles in a square are 90 degrees. So this whole angle S must be 90 degrees, which means that this S2 is equal to 90 minus X. Then I've got all three angles, I've got three angles in this triangle SOR. So this angle and this angle and this angle must all equal 180 degrees because of angles in a triangle. So I'm going to start by saying that S1 plus S2 must be equal to 90, which means that S2 is equal to 90 minus X. Okay, and then S2 plus R1 plus O2 must equal 180 degrees. And that's angles in a triangle. So S2 is 90 minus X, and R1 is X, and O2, I don't know, equals 180 degrees. So this X cancels out with this X, and I'm going to take the 90 over to the other side, where it becomes negative 90, and so O2 is equal to 180 degrees minus 90, which is 90 degrees, and therefore these two lines SY perpendicular to RX.